Today we will be studying about Numpy arrays. Data scientists and analysts usually use Numpy because Numpy is a library that is used to manipulate with the arrays. They are used to initialize, manipulate Numpy arrays by creating, copying, and casting them. Understanding and handling special values like not a number, nan, and infinite numbers, infinity, and practice working with multi-dimensional arrays to enhance your data analysis skills using Python. So NumPy arrays are basically just Python list with added features. In fact, you can easily convert a Python list to a NumPy array using np.array function, which takes in a Python list as its required argument. So what does it mean is that when you want to convert a Python list to a NumPy array, you will need to use np.array function that converts Python list to a NumPy array, and it takes in a Python list as its required argument. In this way, Python list to a NumPy array conversion takes place. And this function also has quite a few keyword arguments, but the main one to know is D type. The D type keyword argument takes in a NumPy type and manually casts the array to the specified type. The code below is an example usage of np.array to create a two-dimensional matrix. You should particularly note that the array is manually cast to np.float32. Import numpy as np, write the code, and if you want to make two-dimensional, simply initialize it with a variable arr is equal to np.array. You will now use round brackets, and in the round brackets there will be a subsequent square bracket followed by the two arrays, and as you know that array always contains us numbers in square brackets. So here there are two arrays 0 1 2 comma 3 4 5, and they have been placed in square brackets, comma D type is equal to np.float32, and if I need to print all this stuff, so what I need to do here is that I would just need to print repr. So what happens if I write this? What will happen? This is the question that many people ask for me, and I want to make it clear. So you will see that I will get 0 1 2, I will get the numbers that have been placed here in the form of float. The dot represents the float. So if I want to print the entire statement, I would need to use this repr represent. So entire numbers will be in what is in the initialized variable. All that stuff will be printed. You see here. So when the elements of a NumPy array are mixed types, then the array's type will be upcast to the highest level type. This means that if an array input has mixed integer and floating elements, all the integers will be cast to their floating point equivalents. If an array is mixed with integer, floats, and string elements, everything is cast to integers. The code below is an example of np.array upcasting. Both integers are cast to their floating point equivalents. And so, if you write initialize arr is equal to np.array and then print it, you will get the result. I just run it, and you see here that the code is an example of np.array upcasting. Both integers are casted to their floating point equivalents. You see 0 is an integer, 2 is an integer, and 0.1 is a floating number. So integers will be casted to floating point numbers. So if you need to understand what is copying in NumPy arrays, make sure that copying is similar to Python list. And when we make a reference to a NumPy array, it does not create a different array. Therefore, if we change a value using the reference variable, it changes the original array as well. We get around this by using an array's inherent copy function. The function has no required arguments and it returns the copied array. In the code example below, I show here, so there are the elements. A is an variable, B is an variable, C is equal to A. So there are three basically initialized variables, and when you need to print the A array, what happens is print array A dot format repr A. So what happens here is that print array A dot format repr A C0. So I will need to insert 5 at the first place. So that is why I wrote C square brackets 0 is equal to 5, and then print array A, again curly brackets dot format repr A. repr stands for represent A. Now as we move forward, it gains into D is equal to B dot copy the elements of B and place it in D, and when you copy the elements of B and paste it in D, initialize in the D variable, you can then edit it. You can then change it by inserting 6 at the first position, and when I run it, you can see the output. That is quite clear. So now the numbers have been changed as I earlier suggested. So this is what happens here. You see the array type A is now, first it was 0, now it has become 5. Now moving forward, we studied about what is NumPy, then we came upon copying, and then we are landing on to casting. We cast NumPy arrays through their inherent as type function. The function's required argument is the new type for the array. It returns the array cast to the new type. The code below shows an example of casting using the as type function. The dType property returns the type of an array. You see, initialize the entire array with the variable r is equal to np.array. Then we come upon square brackets, and then we come upon the round brackets, and then the square bracket 0 1 2 encapsulates it. Then we want to print it, and we want to know the type of the integers that are within the NumPy array. It will tell us, and then we again initialize is equal to r.as type brackets square brackets will be placed later, but now they are round brackets np.float32 print r.dtype, and it has printed it. You see, I run the code, so it tells that, as you know, the 0 1 2 is integer, so it tells they are integer. Int 64 is the boolean type, hexadecimal, and then the float32 tells about that the numbers, the float np.float32 is basically a floating number. So now we come upon discover what is not a number. When we do not want a NumPy array to contain a value at a particular index, we can use np.nan to act as a placeholder. A common usage for np.nan is as a filler value for incomplete data. The code below shows an example usage of np.nan. Note that np.nan cannot take on an integer type. You see, np.nan cannot take an integer type. So I run there np.array, then these round brackets, and then the square brackets np.nan, 1, 2 print repr. So what happens here is, show you array nan 1 dot, so it comes only with floating numbers. You can see clear here, and with these string numbers. So a string, it represents a string. When I printed it, it printed and it converted it. So in case I uncomment line 8 and run again, you can see that np.array np.nan, 1, 2, d type is equal to np.int32 will result in an error. So to represent infinity in NumPy, we use np.inf special value. We can also represent negative infinity with negative np.inf. So you see, that int bracket np.inf greater than 1000. So r is equal to np.array round brackets and then the square brackets np.inf comma 5. Then I say that int rep and int bracket repr, then the brackets are initialized, and then I will say r is equal to np.array round brackets, then the square brackets minus np.inf comma 1 int round brackets, then repr, then error. Then it will result in an overflow error if we uncomment line 10 and run again. np.array bracket np.inf comma 3 comma d type equal to np.i in 32 np.array round bracket, then the square brackets np.inf comma 3, then the then the square brackets comma d type is equal to np.float 32. I run it and you see the response. So true, yes, it is true. Print the word print np.inf infinity is greater than 1000, yes, and then we say that np.inf comma 5, yes, it is true, array inf comma 5 dot, and it shows me that array inf comma 5 dot array bracket minus inf comma 1 dot. You see, now it's time to code. The first array we will create comes straight from a list of integers and np.nan. The list contains np.nan as the first element and the integers from 2 to 5 inclusive, including as the last and the next 4 elements. So set ar equal to np.array apply to the specified list. Ar is equal to np.array round brackets, then the square brackets np.nan comma 2 3 4 5. I run it and I got the test it. So you see the test case has been passed. Now r2 equal to r.copy, then the set first element of r2 equal to 10, r2 is equal to r.copy bracket r2 0 is equal to 10, and you see the result executing the code. Test cases has been passed. 2 test cases has been passed. The next 2 arrays will use floating point numbers. The first array will be upcast to floating point numbers, while we manually cast the second array using np.float32. For manual test casting, we use an array's inherent as type function, which takes in the new type as an argument and returns the casted array. Set float-r equal to np.array applied to a list with elements 1, 5.4 and 3 in that order. Set float-r2 equal to r2 dot as type with argument np.float32. You see code here, I have coded the entire for you guys. Float-r equal to np.array round brackets, then the square brackets 1, 5.4, 3, and float-r2 equal to r2 dot as type round the square the round brackets np.float32. The final array, if I test it, will be a multi-dimensional array, specifically a 2-dimensional matrix. The 2D matrix will have the integers 1, 2, 3 in its first row and the integers 4, 5, 6 in the second row, while we also manually set its type to np.float32. So we set matrix equal to np.array with a list of lists representing the specified 2D matrix as the first argument and np.float32 as the d-type keyword argument. Matrix is equal to np.array round brackets, then these 2 square brackets for 2D, one that encapsulates the entire 2-dimensional, and the other square bracket is with respective to the array. 1, 2, 3, 4, 5, 6, np.float32. You don't need to encapsulate the argument type. If I now run it, you see the answer. So thank you.